Looking at the surface area of spheres and hemispheres, let's first look at the surface area of a sphere. So think about a basketball, a tennis ball. It is that part that you touch, you can pick up, that surface area. The formula for the total surface area of a sphere is equal to 4 pi r squared. So it is pretty straightforward. Should be able to plug some values into that formula and to get it correct. If we're thinking about a hemisphere though, we're thinking about half of that. So think about a tennis ball and you cut it in half and then it has a flat part on the bottom. So you've cut it in half and it's solid, like there's no air on the inside essentially. So if you put that formula in half, you would then end up with 2 pi r squared. But let's not forget, that just gives us the surface area of the curved bit. Let's not forget the circle down the bottom. So the surface down the bottom is a circle. So you need to add to that pi r squared to get the surface area of the whole hemisphere. So the first part here gives you the curved surface at the top of the hemisphere. The bottom part of the formula here gives you the flat circular surface. So you just need to be careful when you get a hemisphere question, especially with worded problems. Be careful if they're just asking for the curved surface, so this bit, or if you require the bottom part or the base as well. So just be careful with the questions. Okay, so let's find the surface area of these two spheres. Formula is 4 pi r squared. So let's put the values in. The radius here is given. So the volume is going to be equal to 4 times by pi times by the radius squared, which is going to be equal to 4 times 3.14 times by 6 times by 6, which is going to be equal to 452.16. It is meters, and because we are working with surface area, the part that you would feel or paint or touch, squared. Surface area is a square unit of measure. With the second one, you can see that we are given the diameter, so turn it into a radius, 15 centimeters. Then we can put it into the formula, 4 pi r squared, so 4 times by pi times by the radius squared. Then use my calculator, 4 times by 3.14 times by 15 times by 15 is equal to 2,826. It is centimeters and it is squared. Surface area, a measure of square units. Looking at the surface area of this hemisphere, let's actually pretend that that's not a dotted line, and let's actually assume that it does have the two surfaces. So it's got a curved surface up here, and it has the flat circular surface here. So you can see that I've spread the formula out just to try and help us out with our calculations. So 2 pi r squared plus pi r squared. You might be thinking as well, which is great if you are, that that actually equals 3 lots of pi r squared. That's great thinking with your algebraic knowledge if you are thinking that. But I like to split it up, thinking that some problems, depending on the worded problem, you may just need the curved surface. Some you may not need the part inside. It just might be looking for the curve. So just be careful. So the first part is 2 pi r squared, so for the curved surface. So 2 times by pi times by 9 squared. If we're adding on the flat circular surface, it's pi times by 9 squared. Plug into our calculator 2 times by pi, which is 3.14, times by 9 is equal to 508.68. That is centimeters squared. Surface area, square unit. If we're just finding the curved surface, that would be the answer. But I'm looking for both, so 3.14 times by 9 times by 9 is equal to 254.34. Great if you notice that that is half of the previous number. Therefore, to find the answer, we need to add them together, which is going to give you 508.68. Sorry, I've just added that on. Add them together, you end up with 763.02 centimeters squared for the total surface area. So that means the surface area of the curved surface plus the circular base surface as well. For some surface area problems involving spheres and hemispheres, click the screen now.